Alright, if everybody would get their get a piece of paper out, get their Desmos graphing calculator ready to go. We're going to go over this unit test problem by problem, step by step. Hopefully at the end you will feel a little bit more confident before you take yours. Some of my problems may be the same as yours. Some of them will probably most likely be different, but the process will remain the same. So let's get rolling. Problem number one, we have a function right here, and I'm going to highlight different things about the function, and we're going to identify what those are. Okay, so let me go ahead and take a look at this. Now the way they have this written out, this actually is the D value. Alright, that's the midline. Alright, here's our A value. So I can identify different things. Those are pretty much the easiest things to identify. The amplitude is the absolute value of the A value. So right now our amplitude is 22. Alright, we also know our midline. Our midline is our D value. Alright, so our midline is going to be this D value, which is 727. Alright, now I'm going to highlight something right here. We have a little phase shift going on right here. Here's our phase shift. It looks like our phase shift is 80.75 days. So we'll put phase shift. .75 days. Alright, and the easiest thing to kind of recognize right down here, this is the period. That's the length of the period. Whatever that number is in the denominator when you're looking at these formulas here, these equations, alright, that's going to be the length of your period. So the length of this period, it's not our B value, okay? But right here, if it's set up in this form, that's what's going to be very, very useful for you. Period is 365 days. So I'm going to write down what form I'm talking about. Okay, so right now we have L of t equals, I'm going to put amplitude alright, and then we're going to have either a sine or a cosine, but it's going to be a sine or it's going to be a cosine. I'm going to open up the parentheses. You'll always have 2 pi. This right here, whatever number's down here, will always be the length of the period. Then I'm going to put t, that's the letter T, minus whatever the phase shift is. I'll close the parentheses. And then we're going to put plus the midline. So I'm trying to write the words that go in here. Alright? So, right now, I know you're used to seeing this. You're used to seeing A sine bx minus c plus d, and we're gonna talk about this versus this. Okay, this is going to be a little bit easier when you're using the Khan Academy to type things in when it asks you for different parts. You can type it in this way as well, and it'll still work. But right now, I'm just going to use this to identify what's happening. All right, so it says, when is the longest day of the year? Give an exact answer. Okay, so what we're going to do is we're going to write down some certain things over here, and we're going to evaluate it. So, first thing I want you guys to do is we're going to draw just a regular positive sine graph. So a sine graph starts at the midline. It goes up to its maximum, goes down to the midline, goes down to its minimum, and then eventually comes back up to the midline. That's a positive sine. So if I just said y equals sine of x, that's what your sine graph would typically look like. You have a maximum right here, you have a minimum right here. Now, if we go back over and take a look at ours, alright, we do have a positive sine graph, except our amplitude is 22. So what does that mean? That means, oh, that's Scout, settle down. Alright, that means our amplitude right here is 22 units between the midline and the maximum. Alright, now, they've actually told us our phase shift is 80.75 right here. How did I get that? Like what number would you have to put in there to make that equal to 0 in that parentheses? 80.75. So this point right here, I'm going to write 80.75, comma, and our midline is 727, so we'll put 727. Now if we add 22 to that, that's going to put us all the way up here at 749. That's going to be the longest day in minutes. Okay? So what we're looking for is we're actually looking for the t value that goes along with it. Well, this one's not going to be that difficult because we actually know the length of the period. The length of the period is 365 days. So from here all the way across is 365. That means all I got to do, hopefully you can kind of see how this is broken down into quarters. Like that's a quarter, that's a quarter, that's a quarter, that's a quarter. So we're going to take 365, all right, break it down into a quarter, all right, and that's going to give us 91.25. So the distance between right here and right here is just 91.25. Well, if that's at 80.75 already, it's going to take 91.25, add 80.75, all right, and I'm going to get a total of 172. And that's what I'm going to type in as my answer, like the exact days that it reaches its maximum height. All right, that's how you would do it by hand if you didn't have the use of a graphing calculator. All right, but we do have Desmos. So what I'm going to do, I'm going to go over here. I pre-typed it into Desmos. All right, I've typed everything in. I've typed in the function. Only thing I've done is replaced t with x. So there's a midline. Always type in your midline. Y equals 727. But how do you get your graph settings like? So we're going to go over that. So let's start at 0 and go to 365. That's what I'd like to do. So I can. That's basically the length of the period. But you're going to see how this graph doesn't go the sine graph, because it was shifted over. You're not going to see all of it. So you know what? I'm going to go just a little bit further so you can see. Let's go 730. Let's double that. For our y axis, let's go down to, let's say, 700 and go up to 750. And now you'll probably be able to see it a little bit better. So right now, if I'm saying I want you to picture the sine graph, these are the points that are the important points for you to know in your sine graph. All right. Oh, sorry. Here we go. Let's go ahead and trace this. All right, so we're going up, 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 up. There's the 172.49. We're going to go back down, and then eventually go back up to the midline. So this is your positive sine graph when I was talking to you guys about the positive sine graph. All right, so this is going to be the answer I'm going to type in, because you can clearly see that's the maximum height, 172 days since the beginning of the year. All right, so quick little review before we move on to our next question. Quick little review. Let's go back over here. Let's identify different pieces. That 727 represented the d value. All right, even though it was up front, it's still the d value. The amplitude is the absolute value of the a value, which is 22. This part right here helps us give us our phase shift. It's what number you'd have to plug in there to get this part equal to 0. And the period is just that number in the denominator, and that'll help you when you're trying to problem solve. All right, right here, this is not going to be that difficult of a problem. It just says, what is the period of the function? All right, so this is in this form. I'm just going to put f of x equals a sine, open parentheses, bx minus c plus d. All right, so the b value is this value right there. And that's the only piece of the information that we need. We know that 2 pi divided by b is equal to the length of the period. All right, so our b value happens to be 2. So we're just going to do, so 2 pi over b will always equal the length of the period. So we're doing 2 pi over the number 2. These 2's cancel out. And it looks like our period is simply going to be pi units long. And that's what we're going to type in. It's just give an exact answer. So we're going to say it's It's going to be pi units long. So I'm going to go over here, give an exact answer, type in pi, and we're done. Now, on this one it says we're going to use the interactive widget over here. We're going to write this graph, and right now we're just going to use Desmos. All right, just going to use Desmos. Clear this out. Just type in y equals, type in cosine, open up parentheses. Let's take a look at it real quick. Pi over 12, so right here. Type in pi, type in 12. Go to the right, put a little x right there, and see what the midline was. The midline was at 6, plus 6. Alright, so we're also going to use, it's always helpful whenever you guys are doing this and you're using Desmos, just also write in the midline. I'm going to hit home so we can take a look at it. There we go. So I'm going to put a point right here at 0, 7, and the next point I'm going to put is a 6 and a 6. So those are the 2 points, 0, 7 and 6, 6. So let's go over here to Khan Academy. Right now this looks like a sine graph. So what I'm going to have to do to make it look like a cosine graph, I'm going to have to switch those dots. See how I did? Go from here to there. Now I can take that and put this at a 0, 7, and over here I can put this at a 6 and a 6. 6 and a 6 and a 0 and a 7. Let's just double check. 0, 7, 6, 6. You're good to go. And you hit check. So, what are the procedures of using Desmos? Very easy. Just make sure you type it in. Use X. Make sure you're in radian mode. Also type in your midline. So whatever this number is, type in your midline, and that will give you 2 easy points that you can plot accurately. Okay. So, next problem. What is the amplitude? Alright, another easy problem. Alright, hopefully we'll get to some more difficult ones here soon. Alright, so this right here, this is the A value. So I'm going to write A. This is the B value. This is the C value. This is the D value. So I'm going to write down what are A, B, C. We're going to use this problem. We're going to quickly, the amplitude is just 9. The absolute value of A is the amplitude. But we're going to write down, well, what if they ask you for the period or the phase shift or the midline? Okay? Our A value is -9. Just remember, the amplitude is always equal to the absolute value of A. So, our A value is -9. The absolute value of -9 is +9. The B value is pi over 2. Our C value is 6, and our D value is 8. How am I interpreting these? Because I'm interpreting it from this form right here. Okay? So, what does the B value help you find? We just did that one. It helps you find the length of the period. So if I said 2 pi divided by our B value, which is pi over 2, if it says what's the length of the period, that's what you'd have to do. You'd have to multiply both the numerator and the denominator by the reciprocal. Right, these 2's cancel out, these pi's cancel out. You're left with basically 4 pi over pi, and the length of our period would equal 4. Because this pi will cancel out this pi. 2 times 2 is 4. So the length of our period would equal 4. Just remember, the length of the period is always 2 pi divided by B. That will be the length of the period. Now, our phase shift. That's the C value divided by the B value. Alright? So, if I wanted to find our phase shift, that's C over B. Our C value is 6. Our B value is pi over 2. So if I wanted to find our phase shift, this one would be kind of tricky. multiply both the numerator and denominator by the reciprocal. These 2's cancel out, the pi's cancel out. 6 times 2 is 12. So the phase shift would actually be 12 over pi. That's kind of a tricky phase shift. It would be a ridiculous decimal. And last but not least, our midline. All right, our midline is right here. D is our midline. So if they asked you for the equation of the midline would just be y equals 8. And that would be your midline. But ours just asked us for the amplitude. So that's all we're going to type in. If you're wondering why I'm doing all this other stuff, it's because they could ask you about the other stuff as well. Just want to make sure I cover it. Alright, what is the midline? Well, that was easy. We just kind of talked about that. So I'm not going to redo it. Our midlines always are what? D value. So right now, let's take a look at our D value, which is right there. 2. We're just going to write y equals 2. That's the midline. Alright, we're going to use the interactive widget and graph this. Now fortunately, this is kind of already set up for sine, and this is a sine function, so I'm not going to switch the dots on this. All I'm going to do is type that into Desmos. We're going to have an amplitude at 2, of 2. We're going to have a midline of 4. And then we're going to make sure we type it in nice and accurately. So 2 sine 1/3 of x. So let's go over here. Type in 2 sine. Go back to the problem. 1/3 of x. That. Okay. Minus pi over 3. Got a little phase shift here. Minus. Put a little division bar. Pi over 3. Type in the correct midline, which is 4. Alright, now put y equals 4. Alright, looks like we got our graph, so it looks like I can plot right here pi over 4 and 5 pi over 2, 6. So I can plot at pi over 4 and 5 pi over 2, 6. I'm just going to make sure I typed in everything correctly. 2 sine 1/3 x minus pi over 2 plus 4. Alright, here we go. Pi over 4. So we'll go pi. I'm going to go move this up a little bit. Pi and a 4. Now, if you're wondering, I'm going to draw something real quick before we finish this. 5 pi over 2 and 6. Alright, so before I hit check, I want to make sure you guys know this right here is 0. There's pi, so this right here would be called pi over 2. Pi plus 2 pi is 3 pi, so this is 3 pi over 2. 2 pi plus 3 pi is 5 pi, so that's considered to be 5 pi over 2, because you're adding them together and dividing by 2. So 3 pi plus 4 pi would give me 7 pi, so I'm going to put 7 pi, and that's over 2. Right? So if this right here is 5 pi, this right here would be 9 pi over 2. It's just adding them together and dividing them by 2. So that's how I can plot them accurately. So I've got pi and a 4. Alright, you can clearly see our midline right here. There's our midline right there. We have an amplitude of 2. Alright, and so we're at 5 pi over 2, 6. 5 pi over 2, 6. Pi over 4. That's just Chewbacca in the background. My wife's getting a text. Alright, so let's make sure we got pi over 4, 5 pi over 2, 6, and check. Alright, ooh, yay, finally we got one where you have to actually do a little bit of work. It says the graph of the sinusoidal function intersects at its midline, 0, 1, and then has its maximum point at 7 pi over 4, 5. So here's what I'd like to do. On this particular problem, I want you to just draw a midline. Just draw a midline. Notice, I'm not even using graph paper. I'm just drawing a midline. And I'm intersecting it at a 0 and a 1. So I'm just going to put a 0 right here. 0, 1. And then it has a maximum point at 7 pi over 4, 5. So I'm just going to put right here. I'm going to put a point right here. I'm going to call it the maximum, which is 7 pi over 4, 5. I'm going to label it the maximum. Label this the midline. Here's what I want you to understand. Whenever you start at a midline and then you go up to the maximum, that is your positive sine graph that looks like this. So this is going to be a positive sine graph. It's going to go back down to the midline, and then it's going to go back over here and finish somewhere over here. So right here, we're going to break this down into its parts. It's very easy. Its minimum would be right about here. Alright. So we're going to write down different things when we find them. We're going to find the A value, we're going to find the B value. The C value is going to be 0. We're not going to worry about it because it literally starts right here at 0, 1. So it's basically right there on the y-axis. So we don't have to worry. There's no phase shift. If it starts on the y-axis, there's no phase shift. And we're going to find our D value. Now, first of all, the amplitude, that's the easy part. It's just the distance between the midline and the maximum. So what's the gap between the maximum and the midline? That gap is 4. So our A value is 4. B value, dealing with the length of the period. That's kind of tricky. We're going to deal with that. The D value is the other easy part. The D value is the midline. Our midline right here is at 0, 1. So our D value is at a 1. So the only difficult part is finding the length of our period. Now, I want you to see how this is broken into quarters. Alright, so if these are broken into quarters, that means the distance from right here to right here is a quarter of the way there. Well, what is that distance? That distance is 7 pi over 4. So I have to take 7 pi over 4, and I've got to multiply it by the number 4. Because each one of these sections right here would be, if I labeled them all, would be 7 pi over 4 units. Here, 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 and there. So we got to multiply it by 4, and that will give us the length of the period. So what happens? These 4's cancel out, and we're left with 7 pi. Now 7 pi is not our B value, but that is the length of our period. So now we're going to use the formula that we talked about. 2 pi over B is equal to the length of our period, which happens to be 7 pi over 1. Do a little cross multiplication. 7 pi B equals 2 pi. And then all we have to do is divide both sides by 7 pi. And B equals 2 sevenths, which is the last piece of information that we needed to build our function. Alright? So, what's our final answer going to be? This is a positive sine function, so I'm going to write f of x equals 4, because our A value is 4. I'm going to write sine, I'm going to open up a parentheses, I'm going to do 2 sevenths x, because it says enter x as theta when it's radians, plus 1. Now, my suggestion to you is after you build it, before you type it into the Khan Academy and hit check, type it into Desmos and make sure you haven't made a silly mistake along the way. I mean, everybody here is going to make a silly mistake. I'm going to make a silly mistake. So we're going to type it into Desmos just to be sure. So our y value, our midline was 1. That was a 4. Over here, this was 2 sevenths x plus 1. Then we're going to check. Did it start at 0, 1? Yes. Was its maximum at 7 pi over 4, 5? Yes. That gives me confidence to type in the final answer. So now I'm going to take what I've written down, 4 sine, open parentheses, 2 over 7 x plus 1. If you do all the work, you might as well type it in correctly. So I'm just double checking, making sure I typed everything in correctly. Then I feel confident that I'll get it right. Okay, so here we go. This one says, what is the period of the function? So right now, all we're looking for is the period of the function. Once again, I'm going to write everything out. Okay? So I'm going to erase different things now. This part right here, that is your A value. This is your B value. This is the C value. And this is your D value. So our A value is -4, which means we have an amplitude of +4. Our B value is 5. Our C value is 9, and our D value is -7. I want you to understand the period will always be positive. So even if they have even if that said -5, you would not use you wouldn't worry about the negative. That negative is just making sure it reflects it across the y-axis. Don't worry about that negative. Okay? Just like you don't worry about the negative for the A value, talking about the amplitude, don't worry about it if there's a negative in front of there. So even if there was a -5, I would just do 2 pi over 5, and that would give us the length of our, 2 pi over 5 will be the length of our period, so the length of our period will just be 2 pi over 5. Alright, because the length of our period will always be 2 pi over the B value. Just don't worry if there's a negative. Just make sure you choose the positive value of B. Don't worry that if they put a negative there. Okay, so what is our exact value for the length of our period? Just 2 pi over B. And last but not least, it says, what is the amplitude? Well, our A value is 2. So the absolute value of 2 is just 2. Alright, and that's it. Hopefully this video will be helpful when you guys are taking your unit test. Alright, you know what? We're going to do one last question that deals with a more difficult one. So right now, what we're going to do is we're going to do this last one dealing with the pendulum of the wall. That's right, pendulum as it's swinging next to a wall. So I'm going to do my best to draw a picture of what's happening. So I'm going to go over here. All right. So this is a bob. It's on a pendulum. It's going to be swinging back and forth. I'm going to call this the wall. And so if you see this going back and forth, like this, it's getting closer to the wall, it's getting further away from the wall. Closer to the wall, further away from the wall. So this right here, this is considered to be its minimum distance to the wall. This is considered to be its its average distance from the wall. And this is considered to be the maximum distance from the wall. So if you wanted to draw this, you can call this bob. That's the bob swinging back and forth from a fixed point right up here. Tick tock, tick tock. Over here. So right now, I'm going to draw that out and kind of label some things. So it says has different pieces of this function. We're just going to write down what those pieces are. It says it has a period that's equal to 0.8 seconds. Alright, so write that down. Amplitude is equal to 6 centimeters. Midline is at 15 centimeters. And then it says at the time when it's 0.5 seconds, the bob is at its midline. All right, that's going to help us right there. At 0.5 seconds, a half of a second, it's at its midline. So this is going to be a sine graph. Whenever the graph starts at its midline, I want you to interpret it as a sine graph. So here we go. This will be the last problem that we're dealing with today. We're going to get it right, dadgummit. All right, so right here at half of a second, it's at its midline of 15. All right, then it says it's at its midline, but it's moving towards the wall. So if the bob is moving towards the wall, that means it's getting closer. So we actually have a negative sine graph. So it's actually going to be going down, hit the line, go back up, and then get back to the line. So it's actually going towards its minimum. Then it's going to be heading towards its maximum. All right, this will be pretty easy. Right now we have an amplitude of 6. So we're going to say our A value is equal to negative 6 because it's a negative sine graph. The midline, that's our D value. That's 15. Okay. And they've given us our period. So this is going to be a very easy problem to finish. So I'm just going to kind of draw some things out. We're at the midline, that's at 15. If we add 6, that gets to a maximum of 21 centimeters. And if we take 6 away, that gets us down to 9 centimeters. All right, back and forth. Now it gave us the length of the period. It said the length of the period was 0.8 seconds. So basically it takes 0.8 seconds to go all the way from here to there, 0.8. So each one of these would just be 0.2 seconds. Like each section would just be 0.2 seconds as we get all the way across. But we don't even need to know that for this problem. So right now, I'm going to build the formula with you. So here's going to be the important point. I'm going to write h of t equals, I'm going to write it in words once again. I'm going to write amplitude. All right, the absolute, now the a value, actually, a value is going to be, could be positive or negative. So we'll put a value. So our a value happens to be negative in this particular case. We're dealing with a sine graph, so I'm going to put sine. I'm going to open up a parentheses. I'm going to put 2 pi over the period. Then over here I'm going to put t minus the phase shift. Close the parentheses, plus the d value, which is our midline. All right, so now we're just going to plug in pieces of the information. Now, one thing you need to see right here is the phase shift. So the phase shift is half of a second. All right, because it's half of a second, it's at its midline. So that's that 0.5. So I'm going to put right here for the phase shift, I'm going to put in a 0.5 right here. The d value, which is 15, I'm going to put right here. The a value, which is negative 6, because our amplitude was 6, but it's going towards the wall, which makes it a negative 6, because it's going towards the wall, not away from the wall. I'm going to plug in a negative 6. And the period is the easy one right here. The period is just 0.8. So I'm going to put 0.8 right there. And I'll be done. So here's going to be my final answer. H of t equals negative 6 sine. Make sure you open up a nice parentheses. Put 2 pi right there. Open up the parentheses, put the letter t minus a half all over the period, which is 0.8. Close it, plus 15. And like I said, before I type in, I meant to do a rectangle. before I type this in to the Khan Academy, once again I'm going to type it into Desmos and make sure that everything looks accurate. So here we go. Last thing I'm going to do right now is I'm going to type this into Desmos. Alright, type in -6. Delete all this. 2 pi t minus 0.5. Whole period length is 0.8. Alright, and we're going to go to our graph settings, and we're going to make a reasonable graph out of it. So right now, I'm going to say our x starts at 0, and we'll go all the way over to a 1. And then our y-axis will start at, we'll go 8, because that's 1 below a 9, and we'll go 22. And we should be able to see everything nice and neat. So here we go. Right there, after, look real quick. It's supposed to be after 0.5 seconds. It's at its midline. Point. Maybe I messed up. Oh, there we go. Okay, there it is. Okay. So there it is. After 0.5 seconds, it's at its midline. Then it's going towards the wall, which is right there. Then back up. So this does work. At half a second, it's at its midline, and you can see it's going towards the wall, so it's getting closer to the wall, and right there, there's the 9. Gets back to its midline, reaches its maximum, which should be at 21. So I feel pretty confident now that I've typed all those in, I feel pretty confident that this is going to be the right answer. Alright, so here we go. Let's go and type it in. We have -6, type in sine, open parentheses, fill fraction, 2 pi, parentheses, t minus 0.5, the length of our period, function is period of 0.8, so I'm going to type in a 0.8, had a phase shift of 0.5 right there, and last but not least, it had a midline of a positive 15. Alright, so just double check it, make sure I got everything correct. Alright, check.